I appreciate everybody joining us today. Super grateful that Nicole and Jacob and the PraSaga team are able to sit down with us this morning. It's going to be about 30 to 45 minutes, just an overview, intro into PraSaga, learn a little bit more about the Saga chain and the amazing things that they're doing over there. So I'm going to go off camera and pass it to Nicole and Jacob. Thank you all so much.
Hey, thanks, Red. Good morning, everyone. Good afternoon, wherever you are in the world. Welcome. I'm Nicole Colwell. I'm EVP and Chief Alliance Officer at PraSaga. And we're really excited to be here today and to be part of the Web3athon. Today, I will be joined by our team and by Jacob Holdmann, our Director of Token Relations. We will be covering a bit about PraSaga, giving you some insight, some information about PraSaga history and PraSaga technology, and talk a bit about the use cases and the way that you can use Saga Chain and PraSaga technology in the Web3athon. With that said, I'm going to pass it over to Jacob, who will be leading us off in this presentation. Jacob?
Thank you, Nicole. Thank you, everyone, for taking the time to join us today. Getting a little bit into what we'll go through today, do a quick welcome, a quick overview of PraSaga, a little bit about our history and how we got to the point we are today, why you should develop with PraSaga, our technology, run through a quick demo, kind of showing you the capabilities of what we've put together, and then working with Saga Python and going into the use cases. So PraSaga launched in 2017, originally as an IoT and smart city company. We are a not-for-profit Swiss foundation based out of Zug, Switzerland, and a layer 1 blockchain. We actually like to consider ourselves a single layer because what we've built, there won't be a need for a layer 2 or a layer 0 on our infrastructure. Additionally, we switched to an object-oriented operating system on the blockchain, which I'll get into a little bit later. And we are a completely open source technology. So we're relying on the community to build and help to build the future of Web3. And we're just providing the technology to enable you to do that. Now, a bit about our founders, CEO Michael Holdmann. He started this back in 2017 with Dave, and then they brought Jay along. He had the original IoT and smart city company and the idea of decentralizing it, putting it on the blockchain so that we could have a fully interoperable smart city one day. Dave, he's our CTO. He has been programming since he was 14 years old, started in 1978 with a program called WYSIWYG, what you see is what you get, which went on to become the Wang word processor. And all other word processors were based off of that as well. In the 90s, he sat with NIST and helped write the protocols to make TCP and IP actually do something. And then in 2000, he was actually commissioned by Gateway Computers to help with the dynamic load balancing of the internet when everyone was starting to come on the web, but there weren't enough servers to handle all the traffic. Dave Bieberman is responsible. Without his work, we would not have a Web 1. And without his work in the 90s at working with Gateway, we would not have a Web 2. And then Jay Moore is our CMO. Jay has about 30 years in gaming experience. His largest startup was called Garage Games, which was the largest indie gaming engine out there. Built a community of about 250,000 developers. So as I stated, PraSaga was originally an IoT solution. We were just looking to decentralize IoT and put it on the blockchain. In 2018, when we raised our first round, about 850,000, a fund out of Singapore, Turian Capital, came back and asked us what we were going to do about scale of the blockchain, because none of the blockchains out there at the time back in 2018 would be able to handle the amount of transactions per second, data points per second that were going back and forth on this IoT message bus. That led us to have to go back to the drawing board. We shut down our ICO. We began to research all the layer 1s out there and see if there was something that we could use for our message bus. After about 5 months, we came to the conclusion that it just wasn't possible. And we realized that we had to build our own chain. And so in building this new chain, we had to think of how can we solve problems? What are the problems that exist in today's world in enterprise, on just in the Web3 space now? How can we create solutions for that? One of our favorite quotes here at PraSaga is by Albert Einstein, and is we cannot solve problems with the same thinking we use when creating them. And so we wanted to completely flip the problem on its head and look at it from a different point of view. After our research, in Easter of 2019, our CTO came back and had figured out what the problem to scale was. That was smart contracts themselves. Until we have quantum computing and advanced computing that can work around the current computer laws that we have, smart contracts will only ever be able to move one at a time. So by implementing the operating system, we can now do processes in parallel. So what we've done is it's called the first class object model. It is the same underlying architecture that Windows, Mac OS, and Linux are based off of. A good kind of analogy for this is think of the current layer ones as MS-DOS, where you can only run one application at a time. That's what the smart contract model of blockchain is. What we're moving to is Windows, where you can run multiple applications at one time or send multiple transactions at one time, creating a truly scalable blockchain. And this kind of gets us into our 4 Ps. So our logo is actually 4 Ps connected, not just 2 infinity signs. Those Ps are purpose, people, planet, and philanthropy. And so purpose was the first thing. We had to build a product that had purpose. Where were the problems in the world that we could solve with this technology? We were all in agreement that blockchain technology is something that will change the world, and the introduction of Bitcoin completely shifted the trajectory of our modern world. But how can we take that and apply it to real world problems? Second is people. We want to build on the initial motivation for Bitcoin in giving people their individual sovereignty back and not having to deal with these ridiculous middlemen and fees and such as that in order to transact with someone that you know. And then planet, finding a way to create a more sustainable future, not just for ourselves, but for our inheritance too. You know, we need to figure out a way to kind of right the ship and figure out a new way into the future to protect our planet. And then finally, philanthropy. So one of the parts of our foundation is a philanthropic fund. And so this money will be reinvested back into the ecosystem to help projects come up and develop new ideas and continue to spur innovation and help to build Web3. So now, again, with the smart contracts, as I mentioned, smart contracts are the one thing keeping us from a globally scalable blockchain. Amdahl's law is where we get our information from and our facts from. You can go ahead and look it up, but he wanted to figure out where in a mainframe of a computer you could process in parallel between cores and where they would serialize, meaning go one at a time. And so that is our reason for getting away from smart contracts. And so what we do is we move from smart contracts to smart assets. With our operating system, now everything is an object on the chain. So when you want to create an account, you now create that account directly on the chain, and that is an object on the chain. Say you have a car. That car now also becomes an object on the chain and can be tied directly to your account. So what we've done is we've moved the state of the asset from the smart contract into the individual's own account, meaning you have full ownership of the asset while it is on the chain. And this is really big in enterprise, is the composability of smart assets. You can now use these objects to trace an asset through an entire supply chain line. It keeps the security and decentralization that makes a blockchain while also increasing efficiency and effectiveness. Our operating system, we can realize the full potential of the blockchain and Web3 together. And it also now, with our smart asset infrastructure, allows us to scale to the limits of the internet bandwidth. Now getting a little bit into some of our tech. First is Saga chain. That is the actual chain that the operating system is built on. We use a proof of stake, proof of work hybrid. If you have any more questions on how that works, I'd be more than happy to answer them. Then we have Saga OS, the thing that you'll actually build on. Saga OS was actually written in a modified version of Python. And so this brings the introduction of Saga Python. And Saga Python is a Python-based coding language that any Python developer will be able to quickly pick up and understand and be able to write in as well. And then finally, we have Saga Coin, which will be our native token. So now with the move to smart assets, we are able to solve for global problems. These smart assets are now programmable and are much more nimble in what they can do than a smart contract. With the ability to do processes in parallel, we've also increased the speed of transactions as well. And now with the operating system and something called our CMI has built into it references of code. So whenever someone puts a new object onto the chain and writes the code for that object, that code is stored in the CMI. Now, if someone else wants to put another object, say it was 10,000 skateboards for a skateboard manufacturer. If the next person wants to do 10,000 skateboards again, they just reference the code from that first object. So now you're able to develop faster as well, because you're not writing out every single line of code for an entire program. You're just referencing back to the CMI, the class manager infrastructure, to pull that code from the bank and use it in your program. This code is updatable and always correct. So if there is a bug in the code, the factory setting or the factory output that puts the code out will detect that and will update it. And then any new code will come from the new updated code as well. And so, like I said, Saga Python, this is a very big development for us, because we are also looking for what is the bridge between Web 2 and Web 3. And there's actually a story from Jay Moore, our founder, on his first startup, Garage Games. So in Garage Games in 2004, he sold to Barry Dillard for about 70 million. Barry Dillard took Garage Games, that independent gaming engine, and uses the basis to create Unity. And Unity IPO'd for 32 billion. What was the difference between Garage Games' 70 million and Unity's 32 billion IPO? It was ease of use. Garage Games was command line script and Unity is drag and drop. And so that was one of the core factors that we brought into building this chain, is how do we make it as easy to use as possible? How can we bring Web3 into the greater mass of Web2 developers? Because there are amazing minds in Web2 that just don't want to take the time to learn a new programming language. We do have a walkthrough by our CTO kind of explaining the changes he made, why he had to make those changes, and then additionally doing a walkthrough of what a transaction script would look like. And finally, we have Saga Coin. So Saga Coin is our native token. With the smart assets, we can now find the internal variables to measure things of the internal economy on the chain, such as GDP or CPI, things like that. With that, we actually have 2 world-class economists on board working through equations to create a stabilized currency that can be used as a method of exchange. We're not just looking to create another store of value. We want something that people can spend one day and the person receiving can have faith that that will hold the same value the next day when they go to spend it again. And so now we will get a bit into our demo. So this was a proof of concept that we put together for Bosch Automotive. What Bosch Automotive was looking for, they wanted to see an automotive supply chain on the blockchain. And they were looking for 3 main things. One was a reputation score for suppliers. So if a supplier didn't meet contractual obligations, you were notified. 2 was full provenance throughout the chain. And 3 was if a manufacturer got a part that didn't meet the specs of what they needed, that they would be notified. So if they put it in a car, they know what car it was in, or they would be notified before they put it into the car.
There was a problem statement that was put in from Bosch Engineering and Business Systems. And it was specifically, how can they accomplish capabilities with a blockchain for automotive supply chain? And what they were really looking for in the final analysis was auditing of the entire supply chain for the end customer, for the dealer, for the manufacturers, and all the way down for visibility into the raw material supplier, and ensure that the metal that was used in order to make the screw that's in the motor mount on your car complies with the specifications necessary for it to be in there, right? So all of these things, which aren't really available today, what we came up with and what we actually created was a full digital thread, which is another thing that manufacturing and industry has really been looking for, that they have a holistic view of the entire supply chain, all of the parts that are integrated within any one product or device itself. So this is what the outcome was. Now it's not complete because it was for hackathon and we got so far. All the code to do all of the functions is there and it's available as open source for anybody to look at and play with, but it's not necessarily implemented within this. And I'll talk through some of the functions that aren't implemented and you'll be able to grasp how they are. So the first thing is this would be the view of the dealer. And as you see, they have not gotten any cars yet from their upstream suppliers, Ford or GM, and they haven't sold any cars, so there's no downstream. I'm going to a couple of things here. This right here, this number here, you'll see on every single item that you view, and each one is globally unique and will never be repeated. And this is very important because this establishes the ability to have all 7 billion people in every single entity, organization in the world to have their own unique 256-bit string of random alphanumeric characters that will never be repeated. So that is your identity, almost like your social security number, the VIN number on your car. All of these different things are now represented in a 256-bit string and are part of your account. So anything that you own would be a subset of your overall account unique ID. There's 2 buttons that do work on here, and one of them is new part. What that is a fungible asset, as we call them. There are no tokens necessary within this system because you can actually move possession of an item from one account to another account. We eliminate smart contracts by implementing this extensible blockchain object model, or as people are starting to understand now, a global operating system. So new part is a fungible asset. That means that we can fractionalize it. We can make a batch of them, 10,000 parts or something, and we can fractionalize that and separate them and move them to different accounts. And a non-fungible asset would be one where there's only one unique item. And although new assembly is built from a fungible asset, in actuality, it becomes a non-fungible asset. In this case, in this instance, an assembly, the final assembly would be the vehicle, the car. And there will only be one number associated with that car. However, all of the parts, an assembly can be made up of assemblies. Assembly can be made up of parts, right? It depends on, there may be somebody that's actually assembling the engine that GM is putting in the car, right? So that would be an assembly in an assembly. So that, though, turns out to be a non-fungible token, basically, or in the we call a non-fungible asset, because the car itself will be just that one unique identification number, just like your VIN number. It's replacing basically the VIN number on your vehicle, just digitally. So I can go into any one of these different accounts, and as you see now, we're in Ford's. Again, unique ID. Now we see a much more a broader view because the upstream suppliers for Ford, and in the Bosch problem statement, it said 3 suppliers and do 3 parts each. So it won't be a fast car. In fact, it'll be you carrying a wiper blade, a steering wheel, and a spark plug as you're walking down the street. But in the digital world, this is a car. In the metaverse, right? And then downstream, as you see now, there is a customer here because of the fact that the dealer is a customer of the OEM, of the manufacturer itself. The dealer does not have any customers because they haven't bought a car from Ford yet and haven't moved it down. Now, if we go into any one of these accounts and the supplier, again, you see no upstream suppliers. They have rubber trees in their backyard and they mine all their own metal. However, you see the assemblies and the parts that they do have in their inventory, which is available right now for Ford or GM in order to purchase. Again, as I stated, new parts are fungible assets. And so there's, say, 10,000 wiper blades in this batch. all 10,000 of those wiper blades will always be referenced back to this ID number. So you always know which batch it came from, and that will never be confused with wiper blades that ever came out of another batch. And any of the upstream suppliers that have a certificate, say for the composition of the rubber in the blades, the metal or the ceramics, whatever used in the spark plugs, each of those things, that number will always be associated with this number batch. It would be showing here, and you would see it going all the way through. Now, say that GM or Ford, they wipe out the wiper blades. What you do now is they go ahead and they make 10,000 more wiper blades. Now they have a physical asset or a physical piece that they need to add into inventory and make it available for GM and Ford. All you do is hit new part. And I can go in now and I can do new wiper blades and whatever this is. Now realize, even though this is an automotive supply chain demo, this could be a cosmetic supply chain, pharma supply chain. We don't care what you call these things, right? What we're giving you is the underlying code to make that asset in the blockchain, but you're defining what that asset is. You'll never write a smart contract again, don't have to. And what you do is just create part. You would have a certificate, your SKU, whatever you want in there, but this could also be a bank, and this can be an account, and it can be all of the assets or all the transactions that ever happened between you and the bank. But this time it's immutable on the blockchain, right? I don't have to call the bank anymore and say, what are these different charges from, right? Because they associate completely through. We're the foundation in order to do this, but you would just create part, and now that would have a new part, and they would have a.
So that was the demo that we put together for Bosch Automotive. A couple more things to add into there. So with the object model and being able to put objects within objects, one of the very big things for enterprise especially is you can now hash certificates or credentials onto an account, onto the chain and into an account. So say if Ford had certain specs for their wiper blades, and the components in the wiper blades that the supplier had didn't meet the specs for the car that Ford was building, then those parts wouldn't even show up in the supplier's inventory. They wouldn't be able to buy them because it doesn't meet the credentials needed in order to be compliant with what Ford needs. Another huge area, especially with the full provenance and kind of the really one of the importances of the LOID and being able to track it from raw materials to end unit, is recalls. You now know exactly which bad parts went into cars, so you don't have to spend the time and energy recalling an entire production line or something like that. And so with that, I will hand it over to Nicole to speak a little bit more on the use cases.
Hey, thanks, Jacob. That was great. And as you can see, there's so many different applications that can be built on our chain, so many solutions. And as we're looking through the different topics for the Web3athon, the potential use cases are just endless. Here we have listed those Web3athon use cases. So as you're thinking through what you want to do, what problems you want to solve, what challenges you want to tackle, think about that demo that you just saw and how you might be able to apply something to that. For those who are signing up for the Web3athon, you know that there's multiple use cases here, but as you're also looking forward to solve some of your own challenges on the next slide, we have some of the use cases that we've been discussing with our partners. I come from an enterprise background, so I'm thinking about those challenges that my past customers have had and having those conversations with our partners. Supply chain is one of the biggest, hottest topics these days. For anyone who has gone to the store and not seen things on shelves, you ask, when are you going to get these? I don't know, supply chain problems, right? And this is a great, as you just saw in that demo, that's one of the things. And supply chain goes across all industries. It could be in retail for clothing. It could be in packaged goods, food, automotive, semiconductor. Again, the possibilities are endless with supply chain. But as mentioned in the video, traceability in the food industry is a huge one. We have recalls, outbreaks of different things like Salmonella and E. coli. Being able to have that object-oriented approach allows for flexibility for things to be tracked easier. Healthcare is another one with medical records and verification of different treatments. Cancer is one that, in particular, what's interesting is they used to actually tattoo the person where they had radiation so that if they went to another doctor, they would know, oh, they've had radiation in this part. There are solutions being created that helps to keep that record to the person so that they always have access to it and it's trusted and confirmed about their treatment history, especially in the realm of like cancer treatments, for example. Pharmaceuticals for quality assurance, retail for luxury goods verification. That's a very hot one. If anyone's gone to buy or has heard about how expensive some of the handbags are and the resale value on them, having that traceability and the certification to avoid counterfeits is a big topic, one that I found really interesting having those conversations with a partner. Education, verifying credentials, and then real estate to democratize access to real estate investments. That's another hot topic. The possibilities are endless. And whenever I saw this demo, all of the use cases just started coming based on my experience. And I challenge you to kind of do the same thing, run through and think about all the different possibilities of the things you could solve when working on our blockchain. And so just a few things to note coming up in our timeline. We are launching our testnet in Q3. And our coin will be listed in Q4 and mainnet going into Q1 of 2023. So with that said, next steps. First of all, if you have any questions, feel free to ask. I'm going to run through, a couple of resources we have, and we'll make sure that all of these links are available to you. You can always visit us at PraSaga.com. Our syntax code is available on xbomb.io. And we have a YouTube channel that has a ton of videos about PraSaga and use cases and our technology, and also includes that fantastic video from Consensus with Dave presenting Saga Python, which you definitely want to check out. Then, of course, the Web3athon. You definitely want to sign up for that. I believe, and Rudd, you can correct me if I'm wrong, I believe last day to sign up is the 24th of July. So it's a great time to start doing your research now, getting those ideas going, and get signed up for it for yourself or for your team. And of course, you can follow us on socials at PraSaga Official on most sites. LinkedIn, Instagram, all of the big ones, Telegram, and Discord is where you'll find us hanging out. Great place to come and ask questions at PraSaga Official. If anyone has any questions, feel free to put them in the chat. You can also, again, as you're processing this or you're watching this on replay, you can always come back to our Discord channel and ask questions there.
That was amazing. I really appreciate it. Both of y'all, Jacob, thanks for running through that, and Nicole doing the intro and the use cases and really just explaining all the amazing things that y'all are doing, especially with the roadmap. I know I'm excited about it. Bridging the gap between Web 2 to Web 3 with the Web3athon. It's a great opportunity for everybody. If there are any questions, exactly what Nicole said, you can ask in either their Discord server or the Web3athon Discord server, and I'll make sure that somebody from their team can answer the question more appropriately than I can. But super grateful for everybody joining today and for the PraSaga team. Thank you so much. Looking forward to the amazing ideas that are built, or I guess ideated, and the prototypes that are built.